Okay, so the goal is Mars. How do we get there? I don't know, Elon? A round trip to Mars is estimated to be about 2 billion kilometers. Imagine running a kilometer 2 billion times. Yeah, that's pretty far. But before we try to get there, let's figure out why we would want to go in the first place. Well, obviously we want to get to Mars. Who doesn't want to meet Marvin? But that's not really a reason, so why do we want to get there? First of all, we want to find life. Geologic evidence suggests that about 3.8 billion years ago, Mars had oceans. Not exactly recent, but we might be able to find evidence that life did exist. In 2018, the Mars Express orbiter discovered a subglacial lake of water ice on the caps of Mars. Discovering water ice was crucial because H2O is one of the main ingredients for life as we know it, along with energy and organic matter. Organic matter, we don't quite know where it came from on Earth, and that's another rabbit hole I'm not going to go in, but it might have gotten to Mars as well. This is promising if we want to find any sort of life outside of Earth. Another reason why we would want to go to Mars is money. Let me explain. Most of the resources we have here on Earth, like metals and precious jewels, are not renewable, so we need a new place to get it. Where do we get it? Space, of course. Mars would serve as a great base for any extraterrestrial mining operations we would want to do. Mars itself has a surface made with a great deal of iron and magnesium. Those are both precious metals. And the moons around it also house good materials that can be sold. By the future, we may have an extraterrestrial gold rush on our hands. Now, that's something to think about. Okay, now for the good part. How do we get to Mars? Well, that's kind of a complicated question. The spacecraft would have to travel on an arced path towards Mars formed by the gravity wells made by Earth and the Moon. This distance total would be around 2 billion kilometers for a round trip, and we'd need perfect timing. A possible mission to Mars may take 20 to 60% more fuel to get there because of the distance between Earth and Mars on that particular calendar year. Another thing that we just can't do is scale up our moon missions for Mars. We can't just put more fuel in it and say it'll go farther. There's other complications like how much radiation the crew will intake on the way to Mars, and we don't want them spending 80 years trying to get there. The average amount of radiation just standing on Mars is about 24 to 30 rads per year. This is about 40 to 50 times the average radiation you'd get while standing on Earth. And keep in mind, Mars's atmosphere protects you from most of the solar radiation. Getting there exposes you to much more. In NASA's words, astronauts are exposed to ionizing radiation with effective doses in the range of 50 to 2,000 millisieverts. 1 millisievert of ionizing radiation is equivalent to about 3 chest x-rays. So that's like if you were to have 150 to 6,000 chest x-rays. 1 rad is equivalent to about 100 millisieverts, so that would be around 5 to 200 rads. An absorbed dose of 1 rad means that 1 gram of material has absorbed 10,000 nanojoules of energy. NASA's planned missions to Mars would theoretically take around 2 to 3 years. That is a whole lot more than the 6 months that astronauts are allowed to stay on the ISS due to radiation poisoning. This creates some complications, especially for colonizing, because the habitats would need some serious radiation-protected walls. Now that's enough about radiation for now. We have to talk fuel. 4 different types of propulsion are currently being developed: a nuclear electric/chemical hybrid, a nuclear thermal method, solar electric/chemical hybrid, and an all-chemical propulsion. The distance between Earth and Mars is about 950 times the distance from Earth and the Moon. And Mars's gravity is much stronger than the lunar gravity, so we would need to carry more fuel to be able to even get off and get on to Mars. In short, this means that missions to Mars need to carry much more fuel and use it over a much longer period of time. The amount of fuel needed increases exponentially with how short we want the mission duration to be. That means we have to find this sweet spot to where we're not killing our astronauts with radiation poisoning, but it's not taking forever. Even with all the complications that I just listed, getting to Mars is still feasible. Once we figure out how to deal with all the problems, getting to Mars won't be as difficult as we once thought. But the question is, once we get to Mars, what's next? Thanks for watching my video slideshow sort of thing. Here's all my sources scrolling right now, and have a good day.